Welcome to Science Tutor. Let's discuss endothermic and exothermic reaction. In my previous video, I defined the term endothermic and exothermic reaction. In this section, I'm going to be differentiating between both of them using an energy profile diagram. As an example, let's consider the energy profile diagrams for each cases. So I have two diagrams. Let's call this reaction pathway. Then we have our heat as heat content. So this is 0. This begins with, let's use 100, 200, 300, 400. Okay. Now the same goes here. 0, 100, 200, 300, and 400. This is our reaction pathway. Temperature, reaction pathway, and then this is our heat in joules. Now, using this, the first case I'll draw my energy profile diagram in this form. Then the second case, I will draw my energy profile diagram just like this. Now, in the first case, how can we identify both types of reactions? First, I'm going to calculate the enthalpy, which is the heat content. The heat content is the change in heat content, that is HP minus HR. That is to say, the heat content of the product, remember, this is for reactant, this is for product, this is reactant, while this is for product. Now, the heat content for product in this case, we are making use of 400. So 400 minus that of H arrow is 200. So this gives us a positive 200, which is plus 200 kilojoule. That makes delta H to be positive because we obtained a positive value. Now let's do same for the next one. Now heat content, change in heat content for product minus heat content for reactant. For product, we have 100 minus reactant, we have 300. So that means 100 minus 300 gives us a negative 200 kilojoule. This gives us a negative delta H. What comes to our mind is this. For this reaction pathway, we had the enthalpy change to be positive. So for having positive, it simply means that this is an endothermic reaction. Endothermic reaction. An endothermic reaction simply means that the enthalpy of the product is always greater than the enthalpy of the reactant. That is another way to define endothermic reaction. For endothermic reaction, enthalpy of product is greater than enthalpy for reactant. One piece. Another definition is endothermic reaction, heat is absorbed from the environment, from the surrounding environment, so heat is absorbed. Another way I can also define endothermic reaction is this. The enthalpy of the reactant is less than the enthalpy of the product. Many times students get this confused, but it's vital for them to take note of this so that they don't mix it up. Product greater than reactant or reactant less than product. This defines endothermic reaction. Why? Because we have a positive enthalpy. Now, For the second case, which is what we are having as minus 200, that is to say, since it is negative, this is called an exothermic reaction. Exothermic reaction, heat content, change in heat content is always a negative value. And looking at our diagram, we can also see that the enthalpy of the product is less than enthalpy of the reactant. It is less than that of the reactant. I can also say the enthalpy of the heat content of the reactant is greater than the heat content of the product. This is another way of defining exothermic reaction, different from endothermic reaction. I can also say exothermic reaction is a type of reaction in which heat is liberated to or given off to the surrounding environment. Simple and straightforward. So these two are the different ways in which we can differentiate between an exothermic and endothermic reaction. You can always draw the reaction pathway once you have a good understanding of the definition and how to play around with your reactants and products. And one is lower, the other is higher, and all of that. I'm sure we got value from this video. Please do well to like, subscribe, and share my videos for more persons to see. Have a good time. Bye for now.